Hi, welcome back. Today we're going to start a project on this Syil mill. So let's have a look. Right, what I'm going to do is take this touch screen control panel and integrate it with some other controls into a panel that's going to sit here to make it hopefully easier to operate that mill. So let's run the titles and then join me over at the bench and we'll talk through what I want to do. Right, you'll have to forgive me with this. I never like going handheld. Starting at this end, we've got hookup cable, a USB hub, USB cables and hookup cable, connectors, more connectors. Over here is where it gets a bit more interesting. Here is a rotary encoder. So there's a switch on that, and also it's got indents, so it can rotate continuously, and you can feel stops. You see these in everything; they're everywhere. Then we've got buttons. These are buttons from arcade games, and they've got little LEDs in them that light up. So I'll give you a bit more detail about that in a minute. We've got a couple of rotary switches and an MPG. Now, the MPG, I was toying with that because the machine, if we go over here to the actual mill, it comes with a manual pulse generator as is. However, this integrates directly with a circuit board that's way down in the back there, in the actual control cabinet, which is the most stupid place to put it. It's at the back, you can't get at it. I could interrupt the signal from this and feed it into Mach 3, so it will either work as a Mach 3 MPG and drive the machine through there, as well as driving it through here manually. However, that requires a bit of electronics between the two, and I thought to myself, actually it's cheaper to buy one of these. This is I think this is about $18 pound, so not particularly expensive, a lot cheaper than actually producing the electronics. The electronic solution is a bit more elegant, however this is cheaper, so we'll go with this. We've got an e-stop button. I've got an industrial keyboard, which is stainless steel, meant for kiosks and stuff. It's very old. Got a PS2 connector on it. Focus. However, PS2 and USB for keyboards is pretty much the same thing, and there's a USB socket on it. So there we go. That works. I've tried it. Little sounder. I'm going to change this. This is a 12-volt version, and I think we really need a 5-volt version. Controlling it all is an Arduino. This is a Uno, but we will be using a Leonardo. That's currently keeping my beer warm, fermenting my beer. So moving on, I have a USB XLR connector. I'm a big fan of XLRs. So this will be in the side of the control panel. That's where you're going to plug in your USB stick with your code on it. I have a 3-pin XLR. I can't find a chassis socket for that for the moment, but I will find one. A 5-pin chassis XLR and a 5-pin XLR plug. This will be wired up for the... Let me just try to focus that a bit better. That better? There you go. This will be for a future touch probe. And I need 5 pins because I need power. That's 2 gone. I need a signal to say that it's operating. That's another pin. And the other 2 are touch and e-stop. So hence I need 5 pins. The touch probe is only 3 pin. It only needs to be effectively 1 pin. But I like XLRs because they latch, and also in a dim and distant, when I used to work in telly, these the sockets for these on a tail panel for an outside broadcast truck will last a good 10 years. So they're not only locking, which is good news for anything that vibrates, they're also extremely rugged. So there we have it, a rough selection of bits, and what I'm going to do is just draw a little diagram up as exactly what these things are going to do and how they work. I will just go into these though while I'm thinking about it. This is obviously run, pause and stop. These are going to be overrides. So for instance, spindle speed override and feed rate override, and these two are going to be coolant and misting. I don't have misting, but I'm going to wire it up so that I have the option to add it at some point in the future. Right, buttons. Now here's the thing with buttons. I have a bit of a thing about light up buttons. Brilliant, they tell you exactly what's going on, but they can lie to you. So it's important, I think, that when you press the button on here, it will talk to Mach 3 and say, okay, run the program. I'm going to use a brain then within Mach 3, which is a method of getting signals in and out, to then say, okay, a brain is going to say, right, the e-stop button's been pressed, the program is running, now I need to output a high signal on pin whatever. That pin whatever is going to come back to the Arduino. The Arduino is going to say, okay, we've got a high on pin whatever, now we know that the program's running, so while the program's running I need to drive the LED that's in here. And so the net result is you push the button and you instigate the program to run, but the light won't come on until the program is actually running. And that, I think, is a very useful thing. I'm going to also program up these lights, these LEDs, so that they flash, beep 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 beep, flash when you instigated something and it's not happened, they'll flash. So that tells you immediately there's a problem or a bad connection, the program's crashed, the computer's crashed, whatever. So that, I think, is a very sensible way to wire up these LEDs. Also, it's very easy to get yourself into a bit of a muddle. If I made that so that you push the button and a light comes on, you push the button again and it goes off, that would be fine. But if you then decided to come over here and use the touch screen and press stop or cycle start, whatever, you would be in a situation where the machine is doing something different from the button. So the button would be illuminated, but you could stop it. You could stop it here quite easily. So that, I think, is a dangerous situation. Hence why I'm going to go to the trouble of making this putting this on a feedback circuit. So let me just draw up what I'm going to make in terms of a box. It's going to be made from wood to start with, just so that we can get underway and test it all. So in a blink of an eye, here we are, back with a camera on a set of legs, tripod legs that is, if you're not familiar. Anyway, this is what I intend to build. An LCD, the LCD touchscreen is going to be tilted back, so I need to make a notch in this simple little box. The flat control panel here will have the keyboard on it, e-stop, run, pause, stop, MPG with the feed selector, ×1, ×10 and ×100, and axis selection. So we've got, in the case of that mill, we've got X, Y, Z and A. and then the coolant, feed rate, and the other ones, which I can't remember what they are. Anyway, that's it actually, isn't it? Coolant and feed rate. There's no scale or size to this. The only thing that I want to do is actually to put, if I can, a hinge line down the middle, like that. So a couple of screws there and there, 3, 4, however many, will allow you to open that panel so that you can get access to the wiring. This is only going to be made out of wood, and that's really because I don't know what bits and pieces I'm going to use. I find that what you think you're going to want and use is not always what you end up doing. So I may well end up with fewer buttons on here or more buttons on here, depending on how my use of the mill evolves. So hence why it's made of wood and not metal, and hence why it's going to be easy to get inside to change stuff over. So let's get the wood, and I shall start manufacturing this box. Right, we're just going to score this board rather than cut it through, so it's 4mm birch ply. Right, I've taken out most of the pins because I'm going to round these over, these edges, and I don't want any more pins in there than I have to have. All in all, that's come out pretty alright. You'll notice there's a slight change in the design. Instead of having this piece flat and this piece recessed back, I thought actually it makes more sense to do it this way. It's easier. And yeah, that should look all right, to be perfectly honest. I'll just get the router out and then make all these bits flush and then round them over and see you back here. I have given the box 2 coats of varnish and scraped it so that it's nice and smooth and flat, and put some masking tape over so that I can start to mark out the position of the pots and switches. I've been fiddling around. I think I'm not really sure, but this is a provisional layout. So screen, keyboard, yeah, that's the underside of the keyboard obviously. Over here is an XLR socket, but it's a USB connector. So that's where you're going to plug in your programs. I was going to put it on the side, but I thought actually I then got to put another panel on the side, so it's far easier to just put it in the front panel. And they don't stick out for very far anyway, you know, if you get a small one. Right, e-stop. We have two buttons here for spindle override and feed rate override, and they're going to be connected also with these rotary encoders. So I've yet to work out exactly how the protocol is going to work, but pushing the switch will cause the light to come on, put the spindle speed on, and then you can up and down the spindle speed from here. There's also a switch in here, so that might be that pressing that will reset it to normal. Because of the way Mark III works, yeah, I'm not really sure exactly how I'm going to program that. But anyway, so we've got spindle speed override, feed rate override. Down here we have coolant on and off. I don't have mist on my machine yet, but I do intend to put it on at some point. So I've put a button in for mist. Here is program run, pause and stop. Here is the MPG for positioning the table and the workhead, and I don't know excuse me, I don't know whether I'm going to need to have another switch, so I've left a space here for another one of these switches. I might need a switch to put this into MPG mode. However, I think I might be able to use another one of these rotary encoders. You can, within Mark III, use a slider to set the speed that the jog buttons work at. Hang on, let me just turn this over and I'll show you what I mean. There we go. You can use the up, down, left and right and page up, page down keys to drive the head and the head up and down, and the table left, right, backwards and forwards. And the speed that moves, you can select. So I might use this rotary encoder as a method of setting that speed. I'm not entirely sure that that's going to work though. So yeah, we'll see. And then we've got two switches. One 3-position, which is times 1, times 10 and times 100 for the MPG sensitivity, and the other switch is 4 positions, which is which axis you're selecting, so X, Y, Z and A. So that's it. There's a gap left here. That's on purpose. I think I might put a 3.5-inch display, so there is a diagonal of 3.5 inch. That fits quite nicely. I'm toying with putting another little screen in just for a bit of future expansion. Something to display stuff that I can't easily display on the main screen without rewriting huge amounts of software, and I'm bloody appalling at writing software. So that's where we are. Next thing is to just split the case. So if I put the switch back in this, there we go, or not, as the case may be. That didn't sound very good. There we go. Hang on. There's something wrong with the switch here. There we go. That's better. Right. Just need to work out, I've got to split the case, so I need to work out how far down to put the split line. Right, this is the switch. It's going to mount at that level. So the case, if I split the case around there, all the way round, then when the lid's going to be hinged on the other side. When it hinges up, this will come up, but it won't catch on the inside of the bottom. split the box. There's the hinge. Fits in there quite nicely. That's a little bit of a useful dodge, I think, to cut it twice, and once with the hinge on the circular saw, so that you actually add the exact thickness of the hinge. So that works. However, there are a couple of mistakes. Firstly, that's not square there. That didn't cut very well. And there's an undercut, because I wasn't paying enough attention. So what I'm going to do is just mix up some sawdust. There's plenty of that on the workshop floor, shed floor, and some glue, and make some filler, and clamp that in there overnight. There's room under here for the air to get in, and difficult to see, but we've not blocked the cooling vents on the top of the monitor. Ooh, nice. Excellent. Buy that. This is how I'm going to hold the monitor in. A simple panel that I've made that fits across there, and it's drilled for the same VESA mount as the monitor. So what I think I'll do is, under each of the screws, if I leave a couple of put a couple of washers, then when the glue's all dry and I take it out, I'll have the thickness of the washers in order to pull the monitor back. So that's the theory, because once this is in, it's in. Right, this has had overnight to dry. I don't think that screen is coming out. That's actually glued in there rather well. Right, this is a little bit precarious, but I'll show you how I did this. Forgive the squiffy pictures, I can't get the camera in the right position, but I've vice gripped a piece of MDF that's big enough to support the box onto the table for the drill, and so now I should be able to put a whole square to the perpendicular to this face. Whoa. Next is to just put these inserts in, which means drilling these holes out. These are currently 8mm, which is their M8s. If you're worried about them splitting, clamp the buggers up. There we go. Slight change of plan. To start with, this is the box as it is. It's been filled and sanded where it needs to be. So this is now ready to spray paint. It's got, I think, 4 odd coats of varnish on it, and it's been scraped. I use a little scraper that I made that takes a standard Stanley blade box cutter blade I should say. So it's been scraped smooth. It's now ready to go. The change of plan was, instead of drilling all the holes in here to fit all of the controls, I'm not completely sure how they're going to function. So until I know how they're going to function, I'm going to just fit the minimum number and then work out how the rest of it all functions, and then I can lay out the panel so it makes more sense. But the three switches that are crucial are run, pause and stop. So the run button is connected to my Arduino while I work on it, but there we go. So the run will go there, obviously. I'm going to turn up a bezel so that it's recessed, so that you can't, because you could easily press these just by glancing your hand over the panel. The run button you'll have to actually put your finger over it in order to push it. So there we go. I've got some yellow paint, and that I matched to as close as I could get out of the choice of two colours, two yellows. So let's take this outside and give it a spray. Right, here we go. Sorry the handheld again, I hate handheld, but that's the easiest way to do this. Right, after as many coats as I had in the tin of paint, that's the back done. This is the front done. As I said before, just with the three switches to start with, because it's going to take a bit of thinking about to get the rest of them working. I've also made this. So, that goes. Oh, blimey! That's done that some good. Right, that's going to bolt onto there somewhere, and the cabinet is going to bolt onto the front of it. So there we go. The tool rack in the back there is going to come off. I'm going to junk the bit of steel that I welded up in a previous episode to hold it be. I'm going to get rid of that. The PC is going to go up there where the monitor is, against the wall, and I'm going to build a little a drawer in here to put the tool rack and a few of the other bits and pieces. There's tools laying all over the place, look. So, and fairy lights. You can't go wrong with fairy lights. Anyway, that's where we are. I think I'm going to call it a day for this episode. And yeah, thanks for watching. Do subscribe and give us a like. And if you think I'm doing anything really silly, then please let me know. It won't be the first time, and it certainly won't be the last. So thanks again for watching. In part 2, we'll put that box together in position by the mill and make the little drawer. So yeah, thanks for watching. See you next time. Take care. Bye bye.